Okay, we're going to do 5, 6 word problems. So what I'm going to do is I'm going to give you some ideas, and then I'm going to do 1 or 2 of the homework problems. We're going to spend a lot of time on this. These are important. This is the real life application of these. Okay, so here's what I want you to put down in your notebook or wherever you write this stuff. We're going to draw, let me see if I can draw this. Most of the time when we're dealing with a word problem, we're only going to deal in the first quadrant. And the reason we only deal in the first quadrant is because we're usually dealing with time and distance. Well, if we're talking about time, we can't go back in time. And if we're talking about distance, unless it's a really specific problem where it's dealing with underwater and then we come to sea level, we don't need to deal with a negative height, okay? And so we're going to kind of stick to this type of problem. So the first thing I want to do, I'm just drawing just a general idea of what's going on. So we have a starting height and we have a parabola that goes up and comes down. Okay, and we're going to talk about the parts. Our x-axis most of the time is going to be time. It could be something else, but a lot of time it's going to be time. And you need to tell what we're measuring. Are we measuring in seconds? Are we measuring in minutes? What are we measuring in? That makes a difference. And then this over here, our y-axis, oftentimes is going to be our height. And this can change, but this is in general. And again, you need to tell me what we're measuring. Okay? Now, let's talk about the different parts of our parabola. The vertex. In real life, the vertex is going to tell us the maximum height. Well, that's still our y-axis. So our maximum height, and it's going to tell us the time of our maximum height. Okay? So if I'm talking about the vertex, I'm saying how high did it get and when did it get that high? And you got to think about which is the x and which is the y. Okay? This point over here, this right here, is our initial height. So if we're standing on a mountain and we jump off of it, we throw something off of a bridge, we start at ground level. This is our initial height. And that is our y-intercept. Okay, so our initial height and our y-intercept are right here. Sometimes it can be 0. If we're shooting a rocket off the ground, our initial height is 0. If we're standing on scaffolding and throw a ball up in the air, then our initial height is not going to be 0. So you got to really think about what's going on. Now here's the key. This is what we've been doing this entire chapter, is right here. This is our solution. We call it a bunch of things. It's a solution. It's a 0. It's a root. It's where the parabola crosses the x-axis. In real life, though, it's where it hits where the height is 0. It's where it hits the ground or hits the water if we're throwing something into the water. This is our final meeting place. It's where it hits the ground. And so these are the parts that we're going to have to take from real life, math world, and interpret them into real life. So I'm going to pick a problem. I'm probably going to do 2. Okay, so let's do, which ones do I want to do? I'm just finding a good one. Let's do number 2 in the homework. So if you didn't print it out, because I'm not going to print out the homework, you need to probably pause the video and then you need to go print it out, okay? So let's do number 2, and I'm going to read it to you, but to save us time, I'm not going to write it all out, okay? When you do the homework, all of the equations are going to come from here. This is in the directions of your homework. 16t squared plus vt plus s. H is our height. T is going to be our time. V is our initial velocity. We're not going to spend a lot of time with this, but if you go to physics, this is going to change everything. If we start with a rocket and it has a really fast initial velocity, we're going to expect it to get really high. If we're just throwing something off a bridge, we're not going to expect this to go thousands of feet in the air, okay? And then S stands for our initial height. And we talked about that's our y-intercept. So that's our initial height. Did we start on the ground? Are we on a bridge? Are we standing on a stool? Are we taking the height of the person into account when we figure this out? So that's our initial height. So we're going to use this equation every time. So number 1 says a ball is thrown from the ground. Okay, you should know what your initial height is. If it's thrown from the ground, you already know our initial height is 0. Okay, so that's good to know. And it has an initial velocity of 32 feet per second. This tells us a couple things. This tells us our velocity, but it also tells us what we're measuring in. We're measuring feet and we're measuring seconds. Okay, so let's write the equation for number 2. So h we don't know, and we don't know the time. We know our initial velocity is 32, and we put our t next to it. And we know our starting height was 0. So you don't necessarily have to write the 0, but you can as you start to get used to these. So all I did was figure out where each thing went. Okay? And so that's number 2. That's our equation that we want. And the question says, how many seconds will it take for the ball to return to the ground? Okay? So I'm not asking you what its height is, but we're going to kind of go through this because I want you to see everything that's going on here. And then you also have to graph it. So let's look at how we're going to solve this problem. Okay, so we're going to say, what's our solution? So there's a couple things we need here before we can graph it. But to figure out our solution, we need to know when the height of this is at 0. Because when it's on the ground, it's not any height. So we need to figure out when does it hit the ground. So that's going to be 0. And a lot of people forget about this. We're going to use factoring and zero product property in this case. But the factoring is going to be pretty simple if you think of it. Because 32 is divisible by, we have a GCF here, and that's why I kind of really talked about GCF a lot. Both of these, and I'm dividing by a negative because I like my lead term to be 1. You can do it either way, it'll work out. So 16 and 32 is divided by 16, and there's a t in each one. We don't have to do magic X or anything. We can just do greatest common factor, and look what happens. Okay, we get t minus 2, and we have it equal to 0. Now it's time to do zero product property. We have 2 factors here. It doesn't matter that negative 16t doesn't have a whole group. It is a group on its own. In fact, if you want to do this, if that makes it seem like a group, then do that. So zero product property means we're going to do 2 little problems. We're going to do negative 16t equals 0. And we're going to do t minus 2 equals 0. Okay, so we're going to divide both sides by negative 16 here. So t equals 0. We're going to talk about that in a minute. And t equals 2. Well, let's think about this. What are we finding out? We're finding out the time that the height of this ball is at 0. Well, where did the ball start initially? At time 0, where was this ball? It was on the ground. So the first time that it is at 0, the first time that it has a height of 0 is at time 0. We haven't thrown it yet. This is what we're really looking for, though. I asked when will it hit the ground, after being thrown? It's going to take 2 seconds for this ball to go up in the air, hit a maximum height, and come back down. Okay, so that's how we're going to do that. Now, the next thing we want to do is graph this. So great, we know when it hits the ground. So let's set up our graph a little bit here. Okay, I like to start setting it up. So let's do, oops, I didn't pick a color. Let me do it again. All right, so I don't want all 3. I just want the top quadrant because we're talking about time. We're talking about the first quadrant only. Well, if we know it hits the ground at 2 seconds, we don't need to count by ones here. And this is where you guys have to be careful with your scales. Well, let's label this first. What did I say we were measuring in? Well, back at the beginning, we talked about feet per second. So that means our time is down here. And the time is the independent variable. The time is going to continue whether you throw the ball or not. But the height of the ball depends on how much time has passed after you've thrown it. So that's why that's your y. This is your dependent variable. Okay? Now I can already figure out my time scale because it goes up, comes back down, and hits the ground in 2 seconds. So I did where I counted by 20ths of a second. 2, 4, 6, 8, 1 second. Actually, mine I could even count by more. Let's see. I think yours you can too, but I'm going to count by this. 2, 4, 6, 8, 2 seconds. And we don't really need to go up to 3, but I'm going to just to show you. Okay, so we already know two points on this parabola. The 2 points we know are 0, 0, because we threw it from the ground, and then it hits back at the ground at 2. What we don't know is what this part looks like. Does it go up really high? Does it come up low? Does it go up like this? So we have to figure out the vertex in order to know how high this ball goes, okay? So we only have 2 points. So guess what? We're graphing a parabola, so we need the vertex. Here's our original equation. H equals negative 16 t squared plus 32t. Now, you could use your graphing calculator, but you're going to have to mess with your window a lot to figure this out. I'm going to use our formula. T equals, this is going to be our x value of our vertex, negative b over 2a. So that's going to be negative 32 over 2 times negative 16. So what do we get there? And this is the work I want to see. I need to see this work. If you're turning crap in and it has no work on it, I know you just copy my answers, and it's making me increasingly more angry. So you should get, at 1 second, we're at the maximum height. Well, now we know our axis of symmetry is 1 second, so we could draw this line. So we know our vertex is on this line somewhere. The question is, well, how high did it go? So we know at 1 second it's going to reach its maximum height. Well, how do we figure that out? We know this from the last chapter. We're going to plug in 1 into our t value because we know it's at 1 second that it reaches its maximum height. So that's what we put in to find the maximum height. Sorry, I don't know why I did that. And so you can just put this into your calculator. Make sure you use the parentheses, or you can do step by step using order of operations. Make sure you're using order of operations or you're not going to get this correct. And so now the height of this ball at 1 second is 16 feet. That's our vertex. That's the maximum height. So now we know what we need to count by. We probably can count by ones. So let me see. And notice I'm not writing every single number, because if you write every single number, it gets all jumbled up and it's hard for the reader to read. A good graph, you don't need to read the word problem. You can look at the graph and know exactly what the word problem is, and you can make a word problem. So don't make it so hard for the reader. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 feet, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and we know at 1 second we're going to be at 16 feet. So I'm going to come over here and I'm going to go 1, 2, 3, 4, 5, 6. And there's my vertex. And now I can draw the trajectory of this ball. Starts at 0, 0. In 1 second it hits 16 feet and it comes back to the ground. Gravity grabs it and brings it back down. The problem with my graph right now, if someone were to look at this, they wouldn't know what this is about. Is this someone jumping off the ground? What are we doing here? And so you might want to label it ball thrown, or throwing a ball, or something like that. So now if I looked at this graph, I wouldn't need to look at the word problem. I know that this ball started at height 0 at time 0, so it started from the ground. It must have been thrown because it didn't just roll across the ground. It went up and came back down. At 1 second, it was at 16 feet high, and at 2 seconds, it came back down to the ground. So I know exactly what was going on in this problem. And in fact, you could backwards work this as you get higher level and figure out its initial velocity from that. Okay, let's do one more problem. Let's do number 6, and this is the last one I'm going to do. Again, this is from your homework, so you're getting some homework problems done. So let's do number 6. Number 6 says, again, we're using the same equation from before that we talked about, so I'm going to write that down just so we have it. Negative 16, and this is from the very first, in the directions of your homework, this is where this is, and it gives you all the information, but people like to skip over that. Okay, so Luana hit the volleyball into the air. Initial velocity, okay, so we know that. V is going to be 24 feet per second. We know what we're measuring by now, feet and seconds. From initial height of 3 feet, well, we're talking somebody hitting a volleyball. You don't hit a volleyball off the ground, so she had it out in front of her, and she hit it. It looks like it probably was an overhand hit. I bet this was an underhand hit for volleyball, because if she was throwing it up and hitting it, it would be higher than her height. So we can make the assumption at this point that she's doing an underhand serve. So that's also interesting that there's some things you can do. Okay, so it says initial height, so S is going to be 3 feet. Okay? And the first thing is, and then it does ask a question, how long does it take the ball to reach a height of 12 feet above the ground? So we're going to talk about that at the very end. We first have to come up with everything because we don't know the vertex. We don't know anything about this. And so how can we figure that part out? So let's get our equation done first. H equals negative 16 t squared plus 24t plus 3. Okay? So let's start with the vertex in this case. Well, or do we want to figure out when it hits the ground? It's kind of up to you. This one's going to be a little harder, and so I'm going to use 0 equals, this is not factorable, 16t squared plus 24t plus 3. It's not factorable. Completing the square is not a good idea, so I'm going to use quadratic formula here. So I'm going to come over here, and I'm going to find the solution where it hits the ground by using quadratic equation, or quadratic formula. So I need to do the discriminant first. Well, first we need to do a, b, and c. A is negative 16, b is 24, and c is 3. Let's find our discriminant. Our discriminant is going to be, and if you didn't do this lesson, you're going to have a hard time with this, 24 squared minus 4 times a times c. Okay, so let me do this. I have my calculator here. Good thing. 24 squared minus 4 times negative 16 times 3. So we get our discriminant is going to be 768. So we know we have two real solutions. Okay, so now we got to finish the quadratic formula. So negative b, and you might need to go look this up again, plus or minus the square root of the discriminant, 768, all over 2 times negative 16. And this work I expect to see on your paper or on a separate sheet that you turn in. I'm not just pulling these answers out of my head, and neither can you. So you need to show the work. Okay, so now let's simplify. Negative 24 plus or minus square root of 768 over negative 32. Now I'm going to get my calculator again, and I'm going to do negative 24 plus 768, square root of 768 in parentheses, divided by negative 32. And then I'm going to do negative 24 minus the square root of 768 over negative 32, and the top needs to be in parentheses. So get your calculator out, and let's see what we find out. So I do negative 24 plus the square root of 768, and we're dividing that by negative 32. We get negative 0.11. Now let's think back to what this is. That's our time. Do we care anything about negative time in this problem? We shouldn't, because we're talking about a height. I don't care where the ball was. I guess before she hit the ball, it was on the ground, but let's cross this out. This is an extraneous solution. That one doesn't work. So hopefully the next one works. Otherwise, we did something wrong, which is highly possible when I'm doing work sometimes. And we get 1.61 seconds. So we know that's when it hit the ground. It went up very quickly, and it came back down pretty quick. It wasn't like the ball that we threw. This one goes up and comes down in less than 2 seconds. So we know this is when it hits the ground. So that's my first question. It hits the ground. It's the solution. We have two solutions, but in this case, we don't care about the first one. We only care about when it hits the ground. So 1.61 seconds. Okay. So that's going to help us when we need to graph it. But we also need a vertex to graph it. So now it's time to do our vertex. So we have h equals negative 16t squared plus 24t plus 3. Let's find our vertex. So to find our t value of our vertex, or our x value, negative b all over 2a. And this, let's see if this comes out nice. I don't think it does. So negative 24 divided by negative 32. If you get a negative answer here, you did something wrong. Okay, it takes 3/4 of a second, or 75% of a second, 75/100ths of a second for it to reach its maximum height before gravity grabs it and pulls it back down. Okay? All right, so now we also need to know, well, how high did this ball actually go? All right, well, how do we do that? We do negative 16, parentheses, 0.75 squared plus 24, 0.75 plus 3. Again, I pick up my calculator and I put this in exactly, or I have to be very careful and use order of operations for this. If you don't use order of operations, you're going to get the wrong answer. And you're going to do all this work and your parabola is not going to look right. Okay? Ooh, it looks like I did this wrong initially. So let's see what I got. Negative, oh, I didn't type it in correctly. So I'm checking my work here as I go. So let me see if I type it in correctly into my calculator. I was double checking here. That's never a bad thing, is to double check. Yeah, I get 12 feet. So this reaches 12 feet, okay? It goes up and down pretty quick, but it hits 12 feet at the maximum height. Okay, so now we have what we need. So let's put down here what we need. We know that it hits the ground at, oh, I got to go back up, at 1.1 seconds. So we have 1.61 seconds it hits the ground. And we know that our vertex is 0.75 seconds, and it'll hit 12 feet. Okay, so now we can graph it. We'll put that in later. All right, so let's do our graph, because that's going to how we're going to answer the question. Oh, well, we already answered the question, because it asked when it got to 12 feet. It got to 12 feet at 3/4 of a second, or 75 hundredths of a second. But now the last thing we have to do is graph. Again, we only need the first quadrant because we're dealing with seconds and height. And I'm going to use the scale that I used on the homework because I know that's what you guys have. This time we only have to get up to 0.7, we only have to get up to 1.6 seconds, so I'm going to count by tenths. 10, 20, 30, 40, 50, 60, 70, 80, 90, 1 second. 10, 20, 30, 40, 50, 60, 70, 80, 90, 2 seconds. So this is time in seconds. And I knew what our maximum was going to be because it hits the ground at 1.6. So I went up to 2 just to go a little beyond it. Our maximum height is 12 here. And so we can easily count by ones here to get to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I'm going to stop at 15 because it's a little bit above. And remember, this is our height. And we already found out that we were measuring it in feet. So let's put our points on here. What was the initial height? We'll go back to the problem, and it says our initial height was at 3 feet. So we don't start at 0, 0 here. We're going to start at 3 feet. 1, 2, 3. So there's my initial height. How long does it take to get to the top? Well, it takes 7.5 seconds. So I'm going to go over to, or 0.75 seconds. 1, 2, 3, 4, 5, 6, 7.5 seconds. And we get to 12 feet. So there's my vertex. Okay, and then we hit the ground at 1.6 seconds. So 1, 2, 3, 4, 5, 6. I counted it and I didn't have my pen on. 1, 2, 3, 4, 5, 6. Now we know what our parabola looks like. Okay, and then you need to label this so someone doesn't have to read the problem. So it hits a volleyball. So now we know that someone hit a volleyball at an initial height of 3 feet. It took about 0.75 seconds and it reached 12 feet total. And then it came back down and it hit the ground at 1.6 seconds. I can see all of that just by this graph. So your graph needs to be good enough that I can tell everything from the problem just by looking at your graph. This is going to take some practice. So try a couple of these and see what you can do.